What's up, people, and welcome to my introductory tutorial to blockchains. So in this section we're gonna just dive into the code and have a look at my implementation, and hopefully it'll make sense to you. If you have any prior knowledge to Node.js, that is definitely gonna help you. But if you haven't, please stick around. I'm sure you'll get something out of it anyway. And the theory is still the same, so you should basically. And the introductory point for the application is node. This is actually the folder name, and this is what node it should start. So I type node and then the folder name, which is also called node, unfortunately, and then it's going to load up this index file because it's the default loading point. It's going to pass an argument of the node name that it's going to start. In this case, the node name is node1. You can name this differently if you like. And here it's going to check the arguments that you have specified the right amount of arguments. It's going to read in a configuration file from this name right here. So in that case, the node name matters. In my case, it's node1. So it's going to have a look here in the configurations folder, and in here you have the configuration of different nodes. So in this case, it's going to grab node1.json file. It needs to have this structure. It has an ID, a port number that needs to be free. So if you get into trouble because of the port occupied, you can modify this. And it's going to have an array of different behaviors that I have defined in the behavior folder right here. So for example here, the first thing that it's going to do is it's going to receive the Genesis block. And then after that, it's going to create a buy transaction where it's going to buy something from node 2, and the credit is coming from node 1, and the amount is 500. Then it's going to mine that block in the blockchain, and then it's going to perform another transaction here where it's going to buy something again from node 2 with the amount of 100, and the credit is of course node 1, the current node. Then it's going to mine that block as well. So this is node 1, and the node 2, what this is going to do is basically the same thing. It's going to buy something from node 1 with the amount of 100. And we are going to start with only using one node. But if you want to create some bigger simulation, if you like, you can just create a load of configuration files here and load them up at the terminal and play around with it. So I made this kind of structure for you to be easy to simulate it pretty bigly. So right, and that is how that works. So we will have this configuration file that I just showed you in this variable right here. And then it's going to pass that along to the behaviors module. And it's going to iterate over these and run all the behaviors in this section right here. So you can see it for each of them and grabs the one behavior. And then it checks, sanity check if it actually exists in the module. And then it's going to start it, right? It's going to put it in this object, the behavior tasks object right here. So it's going to append all the functions to this object, and then it's going to run that later down here in the bottom, async.series. So the order matters in the configuration file. It's going to run them in the same order that you have specified them. And this part right here you can ignore for now. You can even delete it because it's not being used. What it does is it sends with HTTP messages between different nodes if you have multiple nodes. But if you're just using one node, that is totally fine. You don't have to use that. And this is also when all node behaviors are run. It's going to call this and log out the output of each task that it performed. And if there was some error, it's going to run that. So I suggest you clone this project and you have a look at how this works. It can be a bit mind-twisting, but my suggestion is that just clone it and play around a little bit with it. I'm sure you'll figure it out. And in this node folder, we also have some other stuff like you don't have particularly pay attention to this, but this is the broadcasting thing, and it's how one node can broadcast to all other nodes. What you need to pay attention to is this part, this topology manager. Here is hard-coded. It probably shouldn't be, but it's hard-coded with all the port numbers and IP addresses of all the nodes. So if if you run a bigger simulation, you need to add them here or read them in through the configuration files or something. So this is the IP addresses and port numbers for that. And in this lib folder, there is nothing. I'm going to delete this, all right? So we also have this behavior folder. And here we specify all the behaviors. We have a couple of helper functions here in the top, like a getter for the blockchain, which is going to be kept in the behavior module, just a list. And this variable here to be mined, that is also just a holdback queue of blocks that hasn't been mined yet. What that means we're going to have a look at later. And then it's going to grab behavior by tag number. You can also look through this, but what is important is this: the behaviors that I add to the behaviors object, right? So merge chain, for example, and set config. Here I take the configuration in that I showed previously. Receive genesis block by 1, mine, and by 2. So you can see here, if you want to implement new behavior, this is important. Here I have a behavior that I put on the behaviors object. The name here is very important. It needs to be the same name that you specify in the configuration tag right here. So in this case, it's by 1. It's going to receive a callback that you need to call when it's done. And it's going to have errors and the response. And this is going to be printed later to the output from the async task. So it's going to grab the behavior from a tag name. So now I have the behavior that is the whole object here, for example, in this case. And then what it's going to do is, in this case, it's going to create a transaction because that's the behavior that it is. It's going to receive a next block number. It's going to get the hash from the previous block that I talked about in the previous tutorial. And then it's going to put all the transactions and the data section of the block. Then it's going to push it to the holdback queue for the blocks that hasn't been mined yet. And then it's going to call onDone. So this is how I implemented the behaviors for the agent, or the node, I should say. And the last thing that I'm going to go through real quick is the block. And this is actually what's going to be interesting when it comes to blockchains, because all the other things is like architecture stuff, but this is actually very relevant to how blockchains work. So if you have a look in here, you can see a couple of interesting things, right? We have this thing called create, where you give it a block number and a previous hash. It's going to create a default block. You can see it defaults to nonce of 0 and just put the data and there is no hash and so on. So that means that you can create blocks that aren't mined yet. It doesn't have a hash. And the way you would do it is you would create a hash, or sorry, you would create a block like this. And then later you would mine that block by putting it in here. And this is going to hash the block, and it's going to create a nonce that is working for you. So it's going to start by checking here on the block if it doesn't have a hash, and also if the prefix of that hash is that the same thing as the prefix that we have defined here. And if it isn't, it's going to keep on changing the nonce until it is. And you can see I have a default value of 4 zeros right here. If you increase this to be something longer, it's going to take longer time for the miner to crunch. But I suggest you keep it at 4 or less, because I mean, this is JavaScript, it's not particularly fast, and also this is a simulation. We don't want to stick around for like 15 minutes in order for it to get done, and if you make it too big, it's not going to be done at all because it's going to take too long time to run. It's going to use a random number for the nonce between 0 and the length of a 32-bit integer. And it's going to string concatenate all the hash content of the block, which is the block number, the nonce, the previous hash, and the block, the data block of the data section of the block. And then it's going to put that on the block object and return it, basically. So you can see an important thing here is that an important thing to mention here is that when it hashes a block, it also includes the previous hash. And that keeps everything in link, because when it hashes, if you don't include the previous hash, it's not going to output the same current hash. And that is going to break the chain. So I hope that wasn't too much for you. There's also the Genesis block here is pretty simple. It just does the same thing but without the previous. I hope that wasn't too much for you, and I suggest that you pause the video, set up the application, play around a little bit with it, and see what it does basically, and look through the code. It isn't that much code, but it can be a little bit complex, so if you haven't taken the time to look through the code in the next tutorial, you might have a little bit problem, stick around. Or you can just stick around and watch the video and see me run the examples. So I hope you guys liked it, and if there is any questions, leave it in the comment section, and I'll see you in the next tutorial.